Another algorithm that's used for both regression and classification problems is called the decision tree. Now, this is a tree-based model. We can import that from the sklearn package or library. Again, how it works, it kind of just recursively traverses, through different splits to make a decision. Okay, so it just looks for features that best separates the classes. So, for example, in this example, the question is, we want to use the decision tree to figure out or answer the question, should I accept a new job? And think of a decision tree as an upside down tree. So we start at the root node. Okay, so from the roots, the goal is to come up with pure nodes. We call this leaves. Okay, so the question is salary at least $50,000, right? So if the answer is no, then we make a decision, decline the offer. Okay, now if it's yes, we make a split, right? So in this split, we ask commute, is the commute more than 1 hour? So if the answer is no, then we decline the offer. We don't want to travel more than an hour, right? But if it's no, then maybe we can consider. So let's look at other features. Does this place offer some freebies or some goodies, right? For example, free coffee for those who love coffee. If the answer is no, then that's a bummer. That's a deal breaker, but for those who love coffee and they do, then clearly we can give it a chance and accept the offer. So this is how a decision tree actually kind of works. So again, here we're going to import pandas to import our data frame. Here for splitting our data, and then here is where we import the decision tree. So we go here, you can see decision tree, we can find it here, decision trees. Again, here there are different types of trees, right? So what we are interested in is this for classification. For regression, it's called tree regressor. So click on this, and we can see these are the different parameters that you can actually pass here. So we've just left everything default. But again, the criteria here, sometimes you can use a Gini or information gain. Again, I wouldn't get into too much of the mathematics there, but there's some information theory going on there, the Shannon entropy. So the option here could be Gini, entropy, or log loss, right? Actually, we can even put this option in the in our example. Again, here you can specify different things, how many splits, default is 2, and so on and so forth. Okay, so all these are just different parameters that we can use to fine-tune classifier to improve performance. And then the rest of the code just remains as the previous one. So here, this is another way to perform some data preprocessing. So here we drop outcome, and then the rest of the columns, we call this X. X will be our training data. And then here we just specify that our data frame should only include the outcome, the last column. We call that Y. Then we use the train split to split both X and Y. And we are using 0.2, 80%. Okay. A random state here just allows us to reproduce this every other time. And then we create an instance of our classifier, and we call this DT_CLF. And then we call the fit function. Again, where the magic happens, we want to, let our model run the relationship between the training data and the predictor features and the target variables, right? So here I just wanted to make some modification here, so I can say, okay, criterion Gini. Okay. Another thing just to keep in mind, decision trees are prone to overfitting. So there are other better approaches like using random forests. Again, we can play around with these parameters here just to improve that performance. The rest of the code remains the same. I think I've already run this before. So you can see once you run that, you can see precision here 70, accuracy 56. What we want to pay attention to is 61%, right? So compared to logistic regression over here, you can see here recall was really bad, 48%, 49%. So there's actually an improvement using decision tree here. All right, and this is what we want. We want to capture as many patients who did actually get diabetes. That's our recall. This is our goal, especially in the medical domain, right? Okay, so out of all those who are predicted, who actually had diabetes, how many were predicted correctly? So in our case here, that's 62%. Okay, all right. So in the next video, we're going to look at naive Bayes.